like to ask the last presentation about the ecological stabilization of raw earth.
Dear member of the Symposium, allow me first of all to express our sincere thanks to you by accepting our communication of this symposium. My presentation will follow the plan below. I do a introduction and material, and I present a material and method, then result of discussion, and I finish with my conclusion. For the introduction, one of the basic human needs in housing in many countries, particularly in Africa, because of strong urbanization, the question of housing has become a fundamental problem. However, the construction sector today are elaborate with modern materials such as cement, sand, iron, and so on and so forth, who cost expensive, and its production generates a strong environmental impact. We have, again, a scarcity of resources and a higher emission rate of greenhouse gases. But faced with the economic problem in developing countries, people often resort to local recycled materials such as wood and clay, and often rudimentary practice. With these practices, we have precarious and dilapidated housing. With a view to improve the building that meets the requirement of economic safety and comfort of the current housing, EFN construction is therefore one of the most solutions, because it is still widely inhabited in the world today, and it used in abundant and in a renewable local resource, and it contributes to the reduction of greenhouse gas emission. Generally, the problem associated with EFN construction are the loss of geometrical characteristics, and we have and we need to stabilize the EF to improve its performance. We can stabilize to obtain a better mechanical characteristic, or obtain a better cohesion of material. We can reduce the porosity and volume variation, and we can improve resistance to rain erosion. We have field have worked on soil stabilization with forest products such as Nere decoction and sheet decoction. For example, we have Brian Swago in 2060, who measured the influence of decoction of the mechanical performance of clay-based material. The addition of the decoction of dairy puts as reglement for water has proved to be effective, because the geometrical materials produced with the mixture of sand decoction of veneer put have values in mechanical strength in monoaxial compression greater than 20% to those obtained without addition of the decoction. We have Cinco Manakinao in 2060, who studies the composite materials based with the powder of the Nere panicole mixed with the EF. The specimen made with this composite material gave better mechanical performance compared to those without the addition of panicole powder. We have Adazabra in 2017, investigate to rise of shea waste as an economical building material in improving the conviction of clay brick manufacturing. And at different temperature, we can have the analysis of a compressed string, have the specimen greater than 5 MPa made. It is possible to show the applicability of shea waste in the manufacture of terracotta bricks to the construction on lawn structure. This paradoxa very little scientifically study makes the use our or adaptation in other contexts almost impossible. Understanding and optimizing and standardizing this natural stabilization practice hold greater potential for today's builder. This is why we studied this term research. In the context of this study, we use the soil taken from the locality of Abome in south of Benin. And the analysis is carried out, the ground tell us so we have a fine percentage of around 50%. The plasticity index is 20 and the liquidity index is 45. According to the IUFRO Research Board classification, the soil is very clay and very plastic sealed. For the stabilization, we use organic adjuvant obtained from the boiled seed of the nearest tree, scientifically called is Parkia biglobosa. The water used to prepare the seed is recovered to be mixed in the soil. The second organic adjuvant used is the residual water from the manufacture of shea butter. The process of making butter is depicted in this picture. We have the shea tree in the right, and the fruit is shielded to have the almonds. These almonds are crushed into particle dense, then rolled and crushed into a paste. This paste is put in a container and shown to change from its initial color to a brown color. Lukewarm water is gradually added to the paste to bring up the scum and leave waste at the bottom of the container. Finally, the residual water is collected and analyzed. The formulation of a geomaterial consisted in making 5 fresh if plus water mixture, a control mixture with 0% for adjuvant, and we adding near solution or shea solution according to the proportion of 25, 50%, 75%, and 100%. The reference consistency of a mixture is that of a mixture used in the practice of traditional construction in some region of Benin, obtained with a pocket penetrometer as shown in this picture at the right. The other brick of tester specimen are made up from the formulated mixture mold without compaction in mold of dimension 10 by 10 by 2 cube centimeter and 4 by 4 by 16 cubic centimeter, then are drying in the open air in a closed enclosure in which the temperature is controlled. The dimension variation of gel material is evaluated by measuring the variation in the length of a 4 and by 4 by 60 type if specimen. The reading of the dimension of the specimen is done using a digital caliper. For the compressing string was measuring using a computer-controlled machine. The specimen with dimension of 10 by 10 by 2 cubic centimeter were subject to dry test according to the permeability test of the Crater Laboratory Manual. This test consists of subjecting the specimens to regular falls of drops of water from a height of 2.5 meters at the rate of 1 drop per second until the perforation or deterioration at the litter. At the end of this test, the result of dimension variation measuring are as follows. We have plotted the curves of the percentage dimensional variation as a function of time in days, and this for the different mixture made with the different rates of advent. We note a degrees in the dimensional variation with an increase in the left in the level of advent. With a mixture without advent, we obtain a rate of dimensional variation of approximately 4.5%, whereas it is approximately 12% for the dosage of 100 Shi and 2.5% for the dosage of 100 Nere. At the compressive strength of geomaterial, we find that it is increased with an increase in the rate of advent. The resistance is improved by 12% with the addition of 100% sheet decoction and 30% with the addition of 100% Nere decoction. For the permeability test, we can also observe that there is an improvement in the perforation time with the mixture with adjuvants. The resistance time of the material with 100% Shi is 4 times longer than the mixture without advent. It is also noted that this time is 7 times longer with the mixture contain 100% of Nere than the mixture without advent. From the results, in conclusion, we can tell it is appear that the addition of organic adjuvant to the IF improve the compressive strength and the resistance to water of the elaborate geomaterial. Also, the results show that the best performance is obtained with the Nere decoction. This work justifies the possibility of using Shi Nere decoction as a stabilizer in the IF construction. Chemical and mineralogy tests on the different material and mixture will provide a better understanding. Thank you for your attention.
Thank you very much. One quick question before we go for a short coffee break, if anybody has one. Yes, Johannes, please.
Yeah, thank you very much for this really interesting results. You mentioned that the material was a mixture of sand and clay.
Yes. Yes.
What was the proportion of clay in your case? And do you have already mineralogical analysis regarding the clay types?
I use a proportion of organic adjuvant. If I take, for example, 100 grams for the soil, I add 55% of this gram for the advent organic. But this mixture is done with the advent organic.
Thank you. I suggest now we take a short break of 12 minutes. Now we'll come back for the final session.